Here we're being asked to identify congruent segments in a plane. So we first have to find the length of each segment. It gives us the endpoints of the segments, JK, MN, and PQ. And we need to find the length first and figure out if they're congruent or not. So in order to find the length, we're going to use our distance formula. So our distance formula we can think of in a couple of different ways. We have the Pythagorean theorem, which just says a squared plus b squared is equal to c squared. And then when we solve for c being our distance, we would get the square root of a squared plus b squared is equal to c, which represents our hypotenuse if we're talking about a right triangle. So when we have some j and some k, we'll just label it like this, even though it might not be the exact coordinates on a plane. Let's say this is j, this is k. And this is going to be some x1, y1 value. This coordinate is going to be our x1, y1. This is going to be our x2, y2. And then if we created a right triangle here, this creates a 90-degree angle. Then we're just talking about the slope here, how it changes. The slope is how it changes from one point to the other, rise over run. And we know that that formula, rise over run, is just y2 minus y1 over x2 minus x1. Same idea here. So we could label these. The rise is y2 minus y1 would be this distance right here, our rise. If we were to label this triangle as, well, let's say this is side A, this is side B, and this is side C, and we're trying to solve for C, well, the distance here is going to be my rise, y2 minus y1, and this horizontal distance would be my run, or B would be x2 minus x1. So I could label it down here a little bit further. A is equal to y2 minus y1, and b is equal to x2 minus x1. And when we plug it into this formula, a squared plus b squared equals c squared, we would have y2 minus y1 squared, or a squared, plus x squared minus, or x2 minus x1 squared equals c squared. And then when we solved it, you would get the distance formula, which is interchangeable here because we know that arithmetic or addition of real numbers is commutative. So it doesn't matter if it's 3 plus 2 or 2 plus 3. So here we get y2 minus y1, which we could easily write x2 minus x1 plus x2 minus x1. Like I said, these are interchangeable here, is equal to c, or our distance. So this is a formula that we're going to be working with, and we can just plug these numbers right in. All we have to do is label these. So if this is j, or my x1, y1, and then my x2, y2, we would just plug it right into this formula, where our distance, we'll label it d now instead of c. Distance is equal to the square root of, let's go ahead and use this, y2. Sorry, mislabeled that. That should be y2. y2 is 8 minus y1 is 5. All of that squared, plus x2, which is negative 7, minus x1, which is 1, squared. And then when we solve for d, we get the square root of 8 minus 5 is 3. 3 squared is 9. And then negative 7 minus 1 is a negative 8. Negative 8 squared is 64. And this is equal to the square root of 64 plus 9 would be 73. And we would just keep it as such. So the square root of 73, because that is probably an irrational number, we'll just leave it like that. This is the exact number. We're not going to approximate to the decimal. We're not going to round. That is the exact length. And when you're dealing with distance and Pythagorean theorem, you're going to get this a lot. The hypotenuse is going to be the square root of some strange number. So we would go ahead and do the same for each of the other segments. Here we have distance is equal to, label these again, x1, y1, x2, y2. The square root of y2, which is 1, minus y1, which is 2, that squared, plus x2, which is 1, minus x1, which is 7, and that squared. That is equal to 1 minus 2 is negative 1 squared is just 1. And 1 minus 7 is a negative 6 squared is equal to 36. So we have here that, I'll put a little arrow here, the square root of 37. So here the square root of 37. And finally, PQ, we'll plug these numbers in. Distance is equal to, we'll go ahead and label x1, y1, and x2, y2. Negative 2 would be my y2. Negative 2 minus negative 6, so that's a negative and a negative become a positive. That squared, plus x2, which is negative 3, minus x1, negative 8, all squared. So here inside we have negative 2, negative and a negative is a positive, so negative 2 plus 6 is 4. 4 squared is 16. And that is added to negative 3 minus a negative, so this would be plus. Negative 3 plus 8 is a positive 5. Squared is 25. When you add these together, 25 and 16 is equal to square root of 41. So here we have the length is square root of 41. And then it says, check all the statements that are true below. Well, are any of these the same? No, JK is not congruent to this would be 73. Is it congruent to the square root of 73? The square root of 37? No, that's not true. And none of them are equal, so none of these are true.